So let's discuss a question from engineering mechanics. This is a very good question. So initially, when the bar is held by two strings of equal length, the tension in each of this initially the tension in each of this are equal before the string is cut. So T is W by 2 initially. Now once the, let's say, this spring is cut, so obviously now this is not in static. I mean, this is actually, this tries to move. Okay, there's an unbalance of force and this rod tries to move. Now just after the string is cut, let's draw the free body diagram of this. So you have, this is the weight. Let's say now the tension, we don't know whether it's T. Obviously there's something else. But let's say this tension is T1. These are the only forces, and because of this unbalanced force, you can see, because of this W creating a moment about the left hand, so this tries to rotate anti-clockwise. So let's draw the inertia diagram of this. The inertia diagram of this is, this rod tries to move now about the right hand being the fixed end. So the center of mass has an acceleration ma. I mean, this when it tries to move, this entire body tries to, the center of mass tries to be in a circular motion. So it has both the tangential acceleration and normal acceleration, and also there is the rotation inertia I alpha. Okay, so this is what is, so it's not in static. I mean, so when, I mean, looking at this problem, what people can think is that when one of the wire is cut, obviously the tension on this wire has to be will increase, because it will carry now the entire weight. But that will happen only when it is a case of a static equilibrium. But the body is not in static equilibrium, so tensions may change. Now we'll find out what is the tension. So this kind of problem, what we do is, we try to write, let's say that, so this, we assume that just once when the wire is cut, when one of the string is cut, the body tends to have a fixed axis rotation about this end. So that's what, so we can have, I mean, the vertical forces should be equal to, or I mean, taking the downward positive, so has to be equal to the ma. Okay, so W is the downward force, tension is the upward, and that has to be equal to mat, right? So this is one equation. We need to get T1, remember. Okay, and another thing is, we can write now m naught is equal to I alpha. This we can write about the center of mass or about the fixed end. So we write about O. So summation of the moment from the left picture, W into L by 2, this is the anti-clockwise moment, there is no other force, so this produces the moment, is equal to I naught alpha. I naught is the mass moment of inertia about O, which is about one of the end of the rod, so ml square by 3 into alpha. This is equation 2. Now this is at. Remember, if the rod is moving about this tangential acceleration of any point, okay, has to be r alpha. So and acceleration, tangential acceleration of g will be r alpha, so L by 2 alpha. So we use this equation as well. So now we need to find T1. So first let's get alpha first from this equation. So this m is W by g, so L by 2, this is W, L square by 3 g alpha. So from this, alpha would be 3g by 2L. Okay, this is alpha, which I substitute here. I get at is L by 2 alpha, so 3g by 4 is what I get from this. L by 2, so 3g by 4. Now this 3g by 4, if I substitute it in the first equation, because I need to get tension, so T1 is W minus m at, which is 3g by 4, mg is W, so W minus 3w by 4, so W by 4. So the string will feel tension, which is W by 4, which is less than the initial tension, which was W by 4. So the tension in fact decreases, and this happens because of the dynamic motion of the rod. Okay, and so you have to consider the problem as a dynamic problem and solve. And the string, now the bar moves in a planar motion, so you have to use both sigma f is equal to ma and sigma m is equal to I alpha, both these equations assume that the body is, obviously when the string is cut for just a fraction of a second, the body tends to move about O. Okay, it's in planar motion, so you have to solve this problem. So it is actually I mean, it decreases, the tension decreases, which is again counterintuitive. But when the intuition is always that one of the string is cut, so it has to be again the entire, this entire right string takes the load W. Now that is false, because that can happen only when the body is in static motion. But here in this problem, the body is in dynamic motion, so you have to consider the problem as a dynamic problem and solve it. So this is very important problem. C is the answer. The tension reduces from W by 2 to W by 4. Thank you.